Hi guys, so the optimization of the model based on the instructions, the individual assignment number 2. So you see the finished model. I added the pie diagrams to make it easier for the optimization. I'll show how to add one more here for the assembly machine. So I'll drag it to the model, double click. I'll change the refresh interval, let's say to 5. Then I need to go to the element states tab, check display element states, and then choose the appropriate machine, in my case the assembly machine. I double click on its name, confirm with OK, and it's gonna work, hopefully. Let's check. I reset the model, do the batch run, and yes, it's working. Now, how do I determine what's the bottleneck, which place to improve? If I start from the back, now we've got the base case scenario. The production is 750 and we are experiencing a loss. So if I start from the back of the model, the painting machine has a lot of extra capacity. This means a lot of idle time. One more thing I can do is I can go to view and choose the keys for machines. We see that the yellow color is idle time waiting parts. So a lot of extra capacity, which means that the problem of the model has to be before this place. If I have a look at the assembly machine, I see that it's either busy or waiting cycle labor. Why is it waiting cycle labor? The worker is 100% busy. So we've got already our bottleneck. But if I start, for example, from the beginning, if I see a lot of idle time, that means that the problem is before that place. The purple color means that element is blocked and the problem is past this place. In this case, we see that what we need to optimize is this part, which then does not allow the other part performing at its most. So I'll add the worker, I'll double the quantity of worker, confirm with OK, reset the model to 0, I'll do the batch run. For that you need to highlight this little bell. So I'll click on the double arrow, do the batch run. And if I start from the end, again, painting machine, a lot of capacity, extra capacity. This is not the bottleneck. Assembly machine has 50% idle. The problem is not here, but the drilling machine and cutting machine, they've got the purple color. They're being blocked by something which follows after them. And if it's not the assembly machine, it has to be here. Compacting machine, idle time, the problem has to be before the compacting machine. Wash machine, 100% busy, so of course this is the bottleneck now. So I double click, increase the capacity, increase the quantity. We've got 2 wash machines. You always have to check that they're both connected with arrows. That means that they're actually both used in the process. I reset the model to 0. I do the batch run. And if I start from the end, this has not changed at all. This part of the model, the compacting machine, it's a lot of free capacity again. The wash machine, half of the time it's idle and only half of the time it's busy. If it's a lot of idle time, it means that the problem is before the wash machine. In our case, that means that we are not getting enough material for the wash machine. Since the bottom is an active part, I'll double click the button. What I can do is that I can, for example, ask our supplier to double the supplies. So I'll change the lot size to 2. I'll confirm with OK. And let's check now. So the production remained on 1010. Now with the double supplies and double wash machine, the production has actually increased. The profit has changed as well. What's the problem now? The painting machine, a lot of free capacity. Assembly machine, again, either busy or waiting for the worker. We see that that's the case of all these 3 machines, and the worker is 100% busy. So it has to be the worker. I'll add another one, confirm with OK, reset the model, do the batch run. I'm not sure whether this has helped anything. Maybe a little, maybe from 1500 to 1520. If I start from the back again, painting machine, a lot of idle capacity, extra capacity. The problem has to be before. The same goes for the assembly machine. Anyway, the drilling machine and cutting machine, they're both blocked by what follows after them. So since it's not exactly the assembly machine, it's waiting parts for about quarter of the time. It has to be in the rest of the model, which is the compacting machine. Idle time has to be before. Wash machine idle time, the problem has to be before, and we're coming to the supplies again. We can try to increase the supplies once again. In this case, it's not gonna actually work. And we see that the production is the same, even though that we've got we doubled the supplies again. The problem now is in statistics we do not see. So I'll go to type. The problem is still with the supplies. I'll check the statistics of parts, and we're talking about bottoms. This is a lot of rejected bottoms coming to the model. They're actively coming each 10 minutes. They're trying to enter the wash machine. The wash machine works for 10 minutes, but sometimes the wash machine is doing something else. It's blocked by the compacting machine, which is broken from time to time, and so on. So that means that it quite often happens that the bottoms come, the wash machine is busy, so the bottoms drop up out of the model. That's this statistics, number of rejected. And then when the wash machine finishes its cycle, the bottoms are not available and the wash machine has to wait till this interval is over and another batch is coming. So what else could we do? It would be including a buffer on this place so the bottoms do not drop out of the model, or perhaps what could be feasible in reality would be that the inter-arrival time would be faster. So let's try that. I'll confirm with OK, reset the model, do the batch run, and quite high increase in production, about 30% increase of production. And at this moment, the process is extremely even. We see that the painting machine has a lot of free capacity, again. But the assembly machine has only about 4% free capacity. It's about 4% of the time idle. And that goes for the drilling machine as well. Only about 4% of its time it could work more, and it's actually blocked by what follows. The cutting machine has higher percentage of available time, but is blocked by the rest of the process. And if we have a look at the other machines, the wash machine again about 4% available time extra for, or a little bit less than 4%, and the compacting machine either broken down or working. So what we can do now is that we can add extra compacting machine, because sometimes it's not available because it's broken down. But if we do that, we can look at only very small improvement, about the 4%, because the other, or 3.5%, because of the wash machine, and that's it. So at this moment, our profit is 91,656. If we add the other compacting machine, let's check. The profit has improved, but the production has actually improved only about the 3 or 4% we were talking about. And the wash machine is now 100% busy, drilling machine as well, assembly machine as well. And we would have to buy one wash machine, one drilling machine, and one assembly machine to improve the production further. And this way you can continue like forever. Okay, so good luck, guys.